work with, that will represent the whole of the population. But in the experimental researches, like in science and all, they take the confidence level as 99%. And when we take into consideration the confidence level, there is also Z score associated with it. If the participants mostly are from masters, they have also cleared masters, I am sure they will be knowing what Z score is, but I will also tell you here. So for a 95% confidence level, the Z score will be 1.96. There is a calculation for this. If you have any, if you have a doubt or if you are not aware, you can ask me at the end of the session. If time permits, also I can explain. Okay. So after that, the third point of consideration is the standard of deviation. That means how much variation you can expect among your responses, right? Say for example, suppose you have made a survey and the responses, from the responses, 95% of the respondents are saying yes to a particular question, and 5% of the respondents are saying no. This is very clear that the answer should be yes, because 95% is saying yes, we will accept it. But if on the other hand you will ask the question in the survey, and if let's say 48% of the respondents will say that this should be yes, and 52% will say this should be no, then there will be a variation, there will be a confusion. It is very nearby, so there will be greater chances of error. That is why, because this standard of deviation is difficult to determine when you give it for the actual survey, most researchers, they set this value to 50%. Okay, we will take it as 50% as in a worst scenario. So to ensure that the sample is good enough to carry on the research and to represent the population. Then we will find the Z score. So you might have seen in this in your statistics books, at the end of the books there might be some pages related to Z score, chi-square and t-test वगैरह ये सब का होगा. तो see, this is the area we will work on. This is the 95% because I am talking about social science. This is the margin of error. So if I will from 0, if I will take to the right side, it will be positive. If I will take it to the negative side, it will be 0 to this side, to the left side, it will be negative. So if I will divide this 95% divided by 2, because half is the positive side, half is the negative side. So यहाँ पे divide करने से कितना होगा? Can anyone tell me the division of let's say 95% by divided by 2 and tell me the answer? 47.5. When we take it to a decimal point, we will get 0.4750, I guess. So in the table, this is the Z score table. Can you take it? Can you find the 4750? Here it is, 0.4750. And you take the column side 1.9, and you take the, sorry, this is the row side, and you take the column side. This is 0.06. So you add it up, 1.9 plus 0.06. What is the answer? 1.96. So this is the Z score. You can calculate the same way for the negative part also. That will come, the same answer you will get, but the thing is you will get it in the negative part. You can also calculate in the same way for 99%. Okay. So after calculating the, you got, we already know that for a 95% confidence level, the Z score is 1.96. Now comes the important part, which is the determining of sample size. How will you determine? These are the formula. Just a second. So these are the formula. The first one is the Cochrane's formula. How many of you are aware of these formulas for determining of sample size? Anyone? No one? You must have started your research, some of you might be, because I can see my known scholars. Okay, anyways. So this is the Cochrane's formula. You can see at the extreme left. This is the Cochrane's formula, and this is also the Cochrane's formula, but this is for large infinite population, and this is for when you know the population. This n is the population, and this is for the, this is another formula which is the very used formula, which is the Sloven's formula or Yemen's formula. This is for a small or finite population. So I will just tell you what these alphabets or these things denotes, and you can work on it. If you have any doubt, you can ask me later also. Okay. So this n, it represents the sample size. This z square is the z square, and this p is the standard of variation that I already said. We are taking it as 0.50, 50%. And the 1 minus p is again 0.50, and the e square is the margin of error, that is 0.05. Okay. And for this one, when you know the population, you can put the population size in n here. And for the Slovene formula, this is the very easy one. You can put the population here. You can put 1 plus the population size and whole the margin of error का square. You will get the answer somewhere around 384. Like these answers you will get. ये जो यहाँ पे 5% वाला है ना, you will get these kind of answers for the 95% confidence level, because I am talking about the social science research. 95% का we will get these answers. But I am telling you again, you can take more than this. You can take round up. You can take a round up value. You can take more than this. I have seen researchers also working on 1500, 2000, 5000 data. Sir also mentioned our research work on ICSSR collaborative research project. That was a 6-month project. And Sham was also working with us. We have taken 3,600 responses from the different districts. So you can work on more the sample size, less the error. Okay. So this is the sample size determination. And next one is, now do you have any doubt about the Z-score table? If you come across any like two figures, like there is if you check, you will come across two figures in the case of 99%. So there you can just add up and divide, add up the row and column and divide. If you have any doubt, I will tell you later. Okay. The next one is the sampling methods, or the probability or non-probability sampling. Shailaja ma'am was also talking about this in the last session. Most of you must be aware of these sampling methods, the probability and non-probability sampling. There is this kind of probability sampling, which is probability is just random. You are selecting your responses randomly. You're working on your responses randomly. You're selecting, maybe with some particular condition, but it is always random. In the simple random sampling, you just select every response has an equal chance of getting selected, like in the lottery method. Like if you have been given a list of let's say 500 students, and you have been asked to generate 100 random students and select these students for a competition. That is random. Systematic sampling, you take some system, you decide that you will be collecting the some nth or kth unit of the selected responses. For example, you have let's say 1000 respondents, and you want 100 respondents of it. Let's say for a customer purchasing behavior. So first of all, for the 1,000 respondents, you want to select 100 samples. That means the K will be found out by dividing 1,000 by 100. It will be 10. So then randomly you will select some number of customers. That is, let's say you select the second one or the third one. You select third, then because the K is 10, then you will add up 10 to each next number. Like you have selected the third customer, then 3 plus 10 is 13. 13 plus 10 is 23. 23 plus 10 is 33. Like that. This is the system based random sampling. Okay. Then the third one is stratified sampling. Here you select, you make some groups of the respondents or the samples on the basis of some homogeneity. You make some subgroups, like you have to work on some agricultural data, or farmers given agricultural credit. In that case, you can work on, you can divide the farmers on the basis of their land, on the basis of their land holding, on the basis of their type of production they're working on. You just subgroup and divide it into some homogeneous group, and then you can randomly select the farmers. The last probability sampling is cluster sampling. Here you divide the population into clusters. Clusters means into groups. This is actually somehow cost effective because you randomly select some clusters. I will tell you an example. Uh, Suppose you have to work on students across all the colleges in Odisha, colleges and universities. But you select the cluster or the group, and you select uh, randomly you select some 10 or 15 colleges and universities across Odisha, and you survey all the students of these particular colleges. You don't go to the all colleges and universities across Odisha. You have selected some group, some clusters, and you work on those colleges and groups, and you work on those students of those colleges and universities only. So that is cluster sampling. Next comes, we will go to non-probability sampling. What is non-probability sampling? There is uh, the probability is not known here. Here we can only work on, um, if you want to work on some responses, we can work on according to, this is mostly we can say this is according to our convenience it is done. Non-probability sampling. So the first one is convenience sampling, where the participants, suppose I will ask you, you survey the students across the uh, universities of the state, and you will just, what you will do according to your convenience, you will just ask the students of your particular college or university, and you will give the result key. And we, most of the time we cannot generalize that sample response to a whole population, because we are collecting it from a particular university or college. The next one is purposive sampling or judgmental sampling, where we deliberately select participants who meet specific criteria. Like suppose I'm working on a study on the startup challenges that people are facing in Odisha or India. But according to my purpose, I am taking only the women-led startups. I will work on the women-led. So I have just that I will take only the women uh, founders who are working on startups. Okay. So the next one is snowball sampling. This is where we are selecting our respondents, and then we are the existing respondents, then recruit the future respondents. We will ask suppose I'm asking one founder of any startup, and then I am taking referral of that founder, and I'm going to the other startup from the referral that I've got from the previous startup founder. This goes on like in a chain basis. So then we have quota sampling. What is quota sampling? Let's say I have to collect 1,000 responses from the state of Odisha. So what I will do, I will fix a quota that out of 1,000 responses, 600 responses will belong to the female category and 400 will belong to the male category. That is quota sampling. This is somehow you can say a faster alternative to the stratified sampling, because in the stratified sampling also we are doing some groups, we are selecting according to some homogeneous group. Here also we are working on some particular quota that we are taking. So now the question arises how we will design a